Hello guys. So today we will practice some questions of number theory. Okay. So we are actually practicing or doing number theory from it's a high time we are doing this. So uh, we will end our number theory session very soon. But before that, I want to go to that much depth that you can solve any questions on number theory. Okay, like Olympiad questions. Okay, like any other types of questions you can solve. Okay, so that's why I am going to the depth of number theory. Okay, I hope you guys are not feeling bothered. Okay, because um, you guys already understood that number theory is a tough, number theory is little tough. Okay, and we have to give much efforts, we have to give much efforts on it, so that we can solve any questions on number theory. Okay, so let's begin. So the question that we will solve, question that I was going to solve is, suppose so we understood that number theory. So we have already understood that if A by B, B by C, then A by C. Okay, so this is a simple relation. This is a simple kind of relation. I hope you guys understood. So now give me 1 second, okay? Yeah. Okay. So we will practice this question. Okay, note it down, guys. Note it down with me, guys. Note it down with me. Suppose question, show that there are no integers a, b, such that g, c, d, a, b is equal to 3. Okay, and a plus b is equal to 100. Okay, note it down this question, then we will solve. Okay, we will solve it. Note it down first. Okay, done. Okay, here they are saying what? Show that there are no integers like GCD AB. Okay, and also the telling a plus b is equal to 100. Okay, so we will start with a stupid type of solution. Okay, I hope you guys don't mind. Okay, if you want to become a problem solver, then you have to become stupid in solving problems. Okay, I didn't mean that you have to become stupid in real life, but you have to stupid in solving problems. Okay, only in problem solving problems. Okay, so now suppose GCD AB is equal to 3, and they're saying Okay, so these are the two abstract from our question. Okay, this is this one and this one. These are the two abstracts. Now we have to solve. Okay, now we have to solve. Okay, here here what is the meaning of this part? GCTAB is equal to 3 and A plus B. Okay, so first it said what is the meaning of this part? What is the meaning? Tell me, what is the meaning of this part? GCTAB means what? GCTAB means nothing. GCT is just a kind of showing common denominator. Okay. So suppose GCTAB is equal to 3 means what? 3 GCTAB is equal to 3 means 3 divided by A, 3 divided by B. Okay. So if 3 divided by A, 3 divided by A and 3 divided by B, so we can say that 3 by A plus B. Okay. 3 by A plus B. Done? 3 by A plus B. So this is the kind of relation. Okay. This is the kind of relation. That means if A is equal to B. Okay. If A is equal to B and we are saying that 3 by A. So here we see that A is equal to B, then it will be 3 divided by B. Okay. So this is a kind of relation. Okay. Like matching one pattern to another pattern. Okay. This is a kind of relations. So in here 3 by A and 3 by B. So here the answer is 3 by A plus B. Okay. I hope you understood. So now here what is the value of A plus B? 100. Okay. 100. So 3 plus A, 3 by A plus B. Okay. Till this 3 by A plus B till this is correct. If I write 3 by the value of A plus B is what? 3 by 100. So it is cannot be divisible. 3 by 100 is not cannot divisible. That means this value like 3 by 100 is contradicting this. That's why the contradiction we can the sign of contradiction is this. Okay, we are saying that this contradicts 3 divided by 100 is contradicting. Okay, so this is the sign of that. So now we have proved what we have solved this question. We have solved. Okay, so again I will tell you. I will say you I will tell you again what is the actual meaning of this solution. Okay, don't worry, just note it down. Then I will tell you again. Okay, just note it down. Pause the video, note it down. Done? Okay. So now I will tell you again. So what is the meaning of this? Okay. Suppose A plus B is equal to 100, A is equal to B. Okay. GCD A B is equal to 3. That means 3 by A, 3 by B. Okay. If it suppose it can say not GCD. Okay. If I cut the GCD, suppose if it is saying A by B, then is equal to 3. Then also it will be 3 by A and 3 by B. Okay. 3 by B. Okay. I hope you understood. Now here, okay, don't remember this all. Okay, like if this is then this is. Don't remember. Okay, don't remember. Just understand this. Okay, you have to understand this. But if you start remembering these things, like starting remembering the solving pattern, like solving pattern and solving ability, like 3 plus 1. If you learn that how 3 plus 1 is equal to 4, if you remember, then I am telling you, you are going in a wrong path. Okay, so don't remember anything in maths. Don't remember anything. Okay, just understand the things. 3 by A. Suppose So if 3 by A, 3 by B, 3 by B, so then we can write 3 by A plus B. Okay, we can write 3 by A plus B. So what is the value of 3 A plus B? So then we can write 3 by 100. 3 by 100. Okay, so now 3 by 100 is not usable, so this one is contradicting this formula. This one is contradicting this one, so that's why we can write 3 not divisible by 100. Okay, so this is the answer. I hope you understood. I hope you guys understood. So now I am erasing this. I am going to the next question. Okay, I am going to the next question. If you guys are facing with some problems or in understanding some concepts, so you can write me in comment section. Okay, I will try to solve your problems. You can write me in comment section. So now let's begin with the next question, which is an interesting one. Suppose here a n is equal to 1. Okay, I am writing the whole question. Okay, I am writing the whole question. Then we will pick abstract from that. Okay. So if a by n and b n is equal to 1, then a b n is equal to 1. And now we have to do what? A n 1 is equal to 1, b n is equal to 1, then a b n is equal to 1. So now we will solve. Okay. Suppose we will take some integers. Okay. We will take some integers. Taking integers. Okay, so these are the abstracts. Okay, I've underlined. I've underlined those. These are abstracts from this question. No? Taking integers. Okay, like x, y, u, and v. Okay, these abstracts we have taken. Okay, so now let me write a n is equal to 1, then b n is equal to 1. Okay, now I am putting these two abstracts x and y into this. Suppose this become ax plus ny. Okay, so there is no big deal in this question. There is nothing so much complicated in it. Just you have to think, you have to understand, then you can solve it very easily. Okay, so now we are putting these integers into it. Bn, okay, bu plus nv is equal to 1. Okay, done. Now we have to do what? We have to solve, or our answer will be this. Okay, we have to put this, that from this and this we will have to make this. Okay, now we have to multiply. Okay, so this is nv, we have to multiply. Okay, we have to multiply like, okay, so here ab into x u plus n into n into vax. Okay, vax y bu and y in v is equal to 1. Okay, is equal to 1. Okay, yeah. I got it. Suppose in okay, n into vx, then y into bu, and then y into in v. How? Okay, vx ybu plus ynb. V, here is one v, vax ybu and y in v. Okay, so we can say that this is how it is correct. Okay, this is AB. Okay, I hope you guys understood. AB x. Okay? This one, this all. Okay. Okay. Done. AB into xu, then this one is this one, this one. Okay, is equal to 1. Okay, so this is a simple multiplication of these both. Okay, we have to multiply this. Okay, we have to multiply this. Suppose. Okay, guys, note it down till then we will go to the next part. Positive and numerator. Okay, done. Now, okay. The next part I will do here. Okay, the next part I will do here. Suppose here is here we will ax plus ny is equal to 1. We know that already. Okay, multiply. We have to multiply here. We have to multiply bu plus nv is equal to 1. Okay, we have to multiply this one and this one. After multiplying this will happen. Okay, this will happen. Okay, we will do this one also. After multiplying this, we will ab, this one will multiply this one ab into xc. Okay, then n into vax plus n into vx plus y bu plus y nv. Okay, is equal to 1. So then we can say individual this value is equal to 1, individual this value is equal to 1. Okay, n is means universal integer. N became universal integer. Okay, n became universal integer. So that's how we can write a b n is equal to 1. So okay. So here the big deal is this multiplication. Okay, this multiplication is somehow it's a big deal. So you have to just understand this multiplication. Otherwise, it's very easy. Okay. I hope you guys done. Now we will practice okay. Now we will practice another simple question. Okay, guys, note it down. Note it down. Okay, note it down. Then we will solve. Okay, done. Now okay, question is if P is a prime, if P is a prime and P not equals to A, then GCD PA is equal to 1. Okay. Now we will solve this. If P is a prime and P not equals P not divided by A means contradiction, then GCD is okay. Okay, guys, note it down this question first. Then we will solve it. Okay, guys, I hope you noted. Okay, now let's begin with the solution part. Okay, this solution part. Here, what is the meaning of this? GCD PA is equal to 1 means P is equal to 1, A is equal to 1. P is equal to 1, A is equal to 1. Okay, I hope you understand. Now, P is equal to 1. Okay, here now we will again write this P A is equal to T. P A is equal to T. Okay, this is equal to P, so in that case P by D and A by D. P by D and A by D, okay? Same manner. Okay, hence they're saying we all know that D is equal to 1. D is 1. Okay, D by 1. So, oh yeah. Okay guys, let me think this. Let me think about this question. Okay, you guys also think. Okay guys, let's understand this question. I don't know what is the meaning of this part. Okay, what is the meaning of this part? I don't know. Suppose they are saying let GCD PA is equal to D. Okay, then obviously B by P, D by A. Okay, done. Now they are saying P is a prime. Okay, yeah, P is a prime. P means what? P is a prime means 2, 3. So this one is number. So this is not divisible. This is not divisible. Yeah. Oh guys, I've got it here. I've got it. So this one. That's what my key. Okay, now done. Question is done. Okay. Suppose they have said. Okay, I'm doing this again. Okay. Suppose they have said that GCD PA is equal to 1. Okay, GCD P is equal to 1. Okay, this one is done. This is 1. Suppose. Okay, this one is 1. Okay, Now we are putting GCD PA is equal to D. Then D by P D by A. Done? Okay, now done. Now here from here we have given that D is equal to 1. D is equal to 1. Also D, if here suppose D by P D by A. Okay, D by P D by A. But here we have given that D is equal to 1. So if D by P then D by A. So it should be that P by A. Okay, but P here is a prime. But P here is a prime. So P here is a prime. So it is not divisible. So it is not divisible. Okay. So it's not divisible. So it's not divisible. That's why its answer will be that D is equal to P but not divisible. But oh no, sorry, D is equals to P. D is actually equals to P. Okay, from here we have given that D by A, D by P. Okay, this is how D is equal to P, but it is not divisible. That is this. It is a prime number. Okay, then it is a prime number. If it is a prime number, then D should be equal to P. Okay, and also D is equal to 1. That means P is equals to also 1. So here is the answer. Okay, D is equals to P, but it is not divisible. Not divisible. Not divisible. That's why D is equal to 1, P is equals to 1. Okay, I hope you guys understood. Now let's move to the next question. Okay. Here one second. Okay. I'm finding out the question. Okay, so now the question we will do here is suppose show that okay, this question we will solve it together. Okay, this question we will solve together. Show that the square of any integer is of the form like 4k or 8k plus 1. Done? Show that the square of any integer is of the form 4k or 8k plus 1. Okay, we have to show. So show show that the square of any integer is of the form 4k or 8k one. Okay, so here the square of any integer is of the form 4k or 8k one. 4k or 8k plus 1. 4k or 8. Okay, so first we have to understand the question. What actually they are trying to say. Okay, so show that the square of any integer is of the form 4k or 8k one. Okay, so we will start with a stupid. We will start with stupid kind of solving. Okay, we will solve like a stupid first. Then we will see the answer. Now, suppose I don't know what I'm doing. Okay, just give me. I told you again. This is stupid solution we are doing. Okay, you don't have to note it down. Okay. Okay, no, enough is enough. Now we will see the answer. Okay, now we will see the answer. Enough is enough. Now we will see the answer. Delete it. Here they are saying by division algorithm by division algorithm, take a is equal to 2. Okay, write it down. Take a is equal to 2. Okay, by division algorithm, take a is equal to 2. Any integer b is representable as 2q or 2q plus 1. Oh yeah. Yeah. They are taking like this 2q. Oh yeah, this is very. Okay, if suppose if b is equal to 2q, okay. Now we are squaring both sides. But squaring the b, actually b square is equal to 4q square. And suppose this one b is equal to 2q plus 1. Now we are squaring this one also, 2q plus 1 and 1 whole square is equal to be like 2q whole square plus 2 into 2q into 1 plus 1 square is equal to b square. Okay, now I am removing this. Okay, you guys, are you noting down, guys? Noting down with me, guys? You have to note it down with me, okay? You have to note it down with me. Yeah. Means 2q or 2q1. Okay. Now I'm solving this. Suppose 4q square plus 4q plus 1, okay, is equal to b square I hope you guys done. And that one is 4q square, and here one is 4q square. Okay, so b square is equal to 4q square, no? Okay, here that we have to see the answer. Oh yeah, this one is 8q plus 1, no? This one is 8q plus 1. What should I do now, yeah? B is equal to 2q plus 1. Yeah, this one is correct. Okay, so we can write it, suppose 4q into, yeah, 4q into q plus 1. 4q into q plus 1 plus 1. Okay, plus 1. Plus 1. Okay, note it down from this part, okay. This is the next part of it, okay. This part is the next part. This one is the next part. This one is the next part. I hope you guys don't note, pause the video, note it down. Done? I'm removing this. since we know q into q plus 1 is divisible by 2, we get b squared is of the 4 8k plus 1. Done? We get b square is of the form 8k plus 1. So since q into q plus 1 is divisible by 2, we get b square is of the form 8k plus 1. I hope you guys done. Answer. So answer done? Okay. So we have to just prove that in previous form we have seen that 4q into q plus 1. So this whole can be divided by 2. So this part is also can be divided by 2. This part is also can be divided by 2. Like q into q plus 1. So like connecting one pattern to another pattern. Some simple thing. Just stupid thing. These questions are also what stupid like connecting one pattern to another pattern. This is how they are solving the questions. Okay, so this is done. This is done. Now is it is divisible by 2. We get b square is of the form 8k plus 1. Okay, we get b square is of the form. Okay, so this one we can write it as we get b square is of the form 8k plus 1. 8k plus 1. I hope you guys done. Okay? Okay? Because after whole squaring this will happen and we can write q. Like we can write q is equal to k. K is kind of integer. K is equal to q is an integer, like q is an integer. Okay, so we can write q integer as k form. Okay, q is equal to k. So this is what this is. I hope you guys done. Note it down. Okay, so this is for today. I hope you guys enjoyed. Okay, so we will meet in our next lecture. Okay, in our next lecture we will practice more and more questions on number theory. Okay, we will enjoy.